So in this video, we are going to see the design of FIR filter for the low pass filter using a rectangular window method. So for that one, the central position for window is first of all you have to choose the desired frequency response of the filter HD of omega that is given in the question. Then you take the inverse Fourier transform of HD of omega in order to obtain the desired impulse response, small HD of omega, HD of n. Then you have to choose the windowing sequence, W of n, which is a default value. So you can choose based on the question. And you have to multiply with the HD of n in order to get the in order to convert my IR filter into a FIR filter. So H of n is equal to W of n into HD of n. Then you take the Z transform of H of n in order to obtain a transfer function H of Z. Then realize the filter using the suitable filter method. So the commonly used windowing function is rectangular window. So the W of n is equal to 1 for 0 to 0 less than or equal to n, n less than or equal to m, and 0 otherwise. So likewise they have given it for a Hamming window. So if you see W of n, W of n is equal to 0.54 minus 0.46 cos of 2 pi n divided by m for n less than or equal to 0 and n greater than or equal to 0 and it is less than or equal to m, 0 otherwise. So likewise you have a Blackman windowing function. So the barrellet window is also called as triangular window. So that is also given by W of n is equal to 2n divided by m for 0 n, so ranging from 0 to m by 2. Next, let us go for the question. Design a low pass filter for the following sequence. HD of omega is equal to e power minus j alpha. So here the alpha value is 3 alpha omega, where omega, the modulus of omega is less than or equal to pi by 4. So it is ranging from omega is ranging from minus pi by 4 to pi by 4. So this is what I have drawn in the graph for the given sequence. You can see. So it is 0 otherwise. So and they have asked to use the rectangular window. So for this one, the solution, the first step is to draw the graph for the given sequence. So you have to draw the graph like this. Okay. So you can see the cutoff frequency, that is WC, is ranging from minus pi by 4 to pi by 4. So this half of portion it represents a low pass filter. So this is how the low pass filter is. Similarly, if they are given high pass filter, you have to draw it differently, and the cutoff frequency also get varied, right? So the second step is find the symmetric factor alpha. So they are given alpha is equal to 3, that is equal to m by 2, that is equal to n minus 1 by 2. So the n minus 1 value is equal to 6, so n value is 7. Likewise, I can find the value of m, that is equal to 6, right? Then the step 3 is find the HD of it. From HD of omega, if you take the inverse Fourier transform, you will get the value of HD of n. So the HD of n formula is equal to 1 divided by 2 pi integral minus infinity to t infinity HD of omega into e power j omega n into d omega. So you substitute the value of HD of omega. If HD of omega is nothing but e power minus j3 omega. So this instead of minus infinity to infinity, you have to substitute to minus omega c. So that value is nothing but they are given, right? Already given pi by 4, right? Minus pi by 4 to pi by 4. Next, so instead of alpha, you substitute 3. So that is what they have given the diagram, right? So uh, HD of omega is equal to 1 divided by 2 pi into minus omega integral of minus omega c to omega c e power j omega into n minus alpha into d omega. So if we take the difference integration, so it becomes e power j omega n minus alpha divided by j. Since it is omega, so you have to be, differentiation of omega, you should not write omega in the denominator. J into n minus alpha. So it ranges from minus omega c to omega c. So in the omega c, omega, you have to substitute omega c first, then minus of minus j omega c, right? So in this one, you can take n minus alpha and the pi as common. And if you bring the 2 and j to the inside the braces, you will get HT of n is equal to 1 divided by pi into n minus alpha into sine omega c n minus alpha. So if I substitute n is equal to alpha, okay, so this becomes 0. So it should not become 0. So you will get the answer as omega c divided by pi when n is equal to infinity. For n is not is equal to infinity, n is not equal to infinity means you will get the same equation. So uh, so the pi omega c value is equal to pi by 4. So if you substitute pi by 4 for n is equal to 3, HT of n is equal to 0.25, right? So since uh, we need to find the value of impulse response h of n, you have to multiply the h of n is equal to ht of n into omega or omega n. So the omega n value is 1 and it ranges from 0 to 6, right? So if you multiply, you will get h of n, right? H of n is equal to now sin pi by 4 into n minus 3 divided by n pi into n minus 3. So n not equal to 3 and 0.25 for n is equal to 3. So first if you solve h of 3, h of 3 is equal to 0.25. So if I substitute h of 0, so it becomes sin pi by 4 into minus 3 divided by pi into minus 3. So if you cancel that one and if you solve sin pi by 4 divided by pi, you will get the answer as 0.075. So with the help of the calculator, you can solve it. Next, h of 1. So you have to solve up to 0 to 6, right? So if I substitute n is equal to 1, you will get sin pi by 4 into minus 2 divided by pi into minus 2. So you'll get the answer as 0.159. If I substitute h of 2, you will get 0.225. Next, for h of 4, you will get 0.225. Next, h of 5, sin pi by 4 into 2 divided by 2 pi. So if you solve, you will get 0.159. So let me solve it with the help of calculator. So you can watch that video also. Next, if I solve h of 6 is equal to sin 3 pi by 4 divided by 3 pi, that is equal to 0.075. Next, I need to take the inverse transform, is a transform of the sequence h of n. So h of z is equal to summation n is equal to minus infinity to infinity h of n z power minus n. So here n ranges from 0 to 6. So if I substitute for n value is equal to 0, you will get h of z is equal to h of 0 into z power 0. Z power 0 is 1 plus h of 1 into z power minus 1 plus h of 2 into z power minus 2 up to h of 6 into z power minus 6. Now if you substitute instead of h of 0, you substitute that value. So you get 0, it is 0.075, right? Next, for h of 1, you will get 0.159. So similarly, so if you see h of 1 value and h of 5 values are same, similarly h of 0 and h of 6 are same. Next h of 2 and h of 4 are same. So if you solve, you will get the h of z value is equal to 0. This entire value. So we know that h of z is equal to y of z divided by x of z. So you will get y of z is equal to this formula. So how to construct this one using the linear phase FIR filter design. So if you see 0.075. So y of z is equal to 0.75 into x of z. So you can see the plus mark. So if you multiply, you will get this one. So it will go to the 6 z power minus 6 value. Then it get added from this direction. So you get y of z is equal to 0.075 plus 0.075 into z power minus 6. Similarly, if we go the next value, we get 0.159 into z power minus 1 plus 0.159 into z power minus 5. So you see the direction. Next, 0.025. 0.025 it should fall 2 z power minus 1, then 4 z power minus 4. Okay. So next, you have to get 0.25 into z power minus c. So I have connected like this. So if you add this one, you will get the value of y of z. So this is how you have to realize the linear phase FIR filter design.